And here we here. Welcome back to another night of crash course in CSEC maths. Right, who in the chat? Who here? Let's see what's going on. This video live if I'm talking to myself. Right, I've seen people pop out. So they can let your partners know we in the game. Good night, everybody. Good night, Daniel, Kerry, Jamie, O'Neill, Vikash, Dejian, Josiah, Christy, Ranette, Ikesh, Daram. Seeing what's the names there. Hello from St. Vincent. So we're doing construction tonight. You can see that question. Now the thing with the construction questions, you'll only be able to work it along with me like what we was doing last night. When you reach the matrices questions, you can work it along with me. And I have this table here set up as well. 104 people live. Good night, everybody. Elmo voice. Y'all here in the volume, everything good? St. Lucia, Grenada, any house, Guyana, Jamaica, big up everybody. Everybody get it big up. St. Lucia, see that already, Trinidad, obviously. Right. Carrie, Crystal, Alicia, Alika, Alexia, Renisha, Spicy, Anastasia, Priya, Post, whoever. Shemaya, Elisha, welcome back. Josiah, Shemaya, everybody, the full clip. 112 people already in the live. This is free maths lessons. So press like on the video one time. So the YouTube algorithm gonna know what to do. I remember last night halfway through the video and nobody pressing like because they watching the video. Press like on the people. Press like on my video, please. Let your friends them know. What else you can do, boy? If you ain't subscribed yet and you just out here watching this live, but I don't know. I really don't know, boy. What I to do again to make you subscribe? Make yourself bigger to see the calculator. Well, we won't have so much calculations to do, so you ain't really have to see the calculator really. And when doing the board, I'll just be in the screen so that y'all would be able to kind of see what's going on here now. Kind of. I have that light kind of coming on there, but we just doing a little construction tonight. Nothing big. Once again, crying, screaming. That's a normal thing in this house. As my sons them organizing. So buy a calculator for me, and that's tell all to get the calculator hook up. People asking to subscribe to the channel and thing. All they watch the channel and see if all they want to subscribe to the channel. If it's something you want to subscribe to by all means. Let me get started. Enough talk. Using a ruler and a pencil and a pair of compasses only. By the way, I leave my compass in school. I have a big compass that I always use for this kind of exact same purposes, but in school. So I had to use an imaginary compass for all of this, right? But I'll explain. Using a pencil, ruler, and a pair of compasses only, construct a triangle ABC. So I read in here. We're constructing a triangle ABC, where with BC is 6, AB and AC is equal to 8. By the way, this is January 2007. So a triangle ABC. Let me put A on top since we started off with BC. A, B, C. BC is 6. Let's see what I'm doing here. I'm drawing a sketch. Important things. Draw a sketch. Yeah, Mahendra, big up yourself. And BA or AB and AC both 8 centimeters. So this is an easy construction from back in the days 2007 because you have no real angle to construct here. But you'll have to measure, you'll have to use a protractor. Oh shucks, I don't have a protractor here either. So you just totally unprepared by that is already going on. Anyhow, don't be like that for your exam, eh? I just have a ruler. I don't have my compass because I'm in school in 5 Rivers and I'm really feeling to go up there in the holidays. Anyhow, so what you have to do is draw a baseline first, and you have to make sure your baseline is straight. And let's see how bad I draw that baseline, eh? It's not bad to trust that way. Yeah, things rough. So you're drawing a baseline, and let me see this chat up. I just want to put my chat so I could see y'all. Good night to everybody. Right here. Just now I just print all out this so I could see what everybody's saying. When we get the AdMath secret soon, what I really plan to do is go live on Instagram for the AdMath people, but we'll see how that goes. I just try to work on something. So setting a bad example. Yeah, I really setting a bad example here. So you draw your baseline. Your baseline can be any length. Normally a length greater than what you want. And you know you put B, you put dash, you put B. Then you measure off the 6 centimeters. I use in inches so it will show up. And that is 60. So that was C according to our sketch. So this is 6 centimeters here. Your dimensions go in the ending, eh? Don't put your dimensions at the beginning, but I just want you all to be able to follow what's going on. Alright, and then you're taking 8 centimeters, you're opening out your calculator to 8 centimeters, not your calculator, your compass to 8 centimeters like that. And one of my private students who do exams in January say, he see somebody going to the exam without a compass, and he see them using the finger like this and drawing circles. Right, but I don't have skills like that person now to draw. I don't have that skill, but tonight we had to pretend like that going to happen. So you open out your compass. Oh, we'll fall long. You open out your compass to 8. And you make a curve, you stick in your point here and you make a curve like that. And then you open out your compass to 8, again you keep it at the 8 and you make a curve there and it will come like this. Now this point here has to be A because you have 8 there and you have 8 there. So you connect the dots, boom, bam. Right? So everybody pay attention to that, everybody understand that? Right. At the ending, you take your dark pencil now, and you just darken the entire diagram, the important stuff. Because what you had before was construction lines. Don't erase the construction lines. If you do that, you'll be erasing your marks. You put in your dimensions. Already said that this here is 6 centimeters. Any dimension that they gave you, you have to put back. So 8 centimeters. Any dimension that was given, put it back. 8 centimeters. Now people who do technical drawing don't know the proper way to dimension, but they're not going to come down hard on you if you just make a little error in the style of your dimensioning. Once you do something like this, you gain your marks. Now you need to draw a line segment AD. Reading the question here. We need to draw, let's go back to the question. We need to draw a line segment AD such that AD meets BC at D and is perpendicular. So this is the hardest type of construction question is get, because you had to make something called a perpendicular bisector. I'm going to put it in red here. There's a line that coming down there, meeting here at D, and this is 90 degrees. Diagram a little small, my sketch a little small, but I think everybody could see that. I seen it on my phone, so good. So how are you going to construct that now? The simple way to construct that is, let's go back to the diagram. Remember, essentially what we're trying to do is come down here and make a D. Let me see if I have a next color. So the color isn't really coming out too strong, but you kind of see what we're doing. We essentially want a line coming straight down there, but we need to construct it a perpendicular bisector. You can draw a horizontal line here and construct a 90, which I showed you all how to do when in the whole tutorial I have on construction. Or you could open out your compass again, and you're opening out your compass and you're drawing a circle here, and it will cut. So you're sticking your point here of your compass and you're drawing a circle coming down here like this to cut the baseline. What will happen is it will cut in two places. Because this is an isosceles triangle, it will cut nicely like this. When it cuts in these two places, now you stick your compass here and make a curve there and another curve there. This intersection is where you need to connect. Bring it straight down. Everybody understand that? The paper I'm doing is Jan 2007. Shout out to all those who just come in: Queen Ali, Alika, Amanda, Blake, Lexian, Vasudev, Vikash. People chatting about feather and stones. Alright. Please go it over. Yes, I will go it over. What happened here, right? Alright, yeah, so the first thing we do was draw the baseline, then we measure out BC, then we use our compass, we open it to 8 centimeters, curve, open it, sticking here, right? Your compass there, sticking it there, curve again. Where the two curves intersect, that was the point, because 8 centimeters. The question we're doing is this question here, Jan 2007. So using a pencil and a ruler, and they give you the information there. Don't worry, it's a long night. We have about 3 hours of this. Matrices coming in the dance, coordinate geometry as well, going and be in the dance. So you have a long time here to sit down and take in stuff. We'll most likely have to see this again. But this is the most tricky in the past papers. This is the most tricky style of construction that usually comes when this perpendicular bisector come down here. People just get problems with that. Alright, so that's how you do it, right? You open your compass and you draw a circle there. It will cut the baseline at 2 points. You stick your compass in there and you use appropriate length, and then you come down there. Practice that. Some of you all may see it and feel like, yeah, I know that. But practice it. You can run into problems that you didn't foresee. And remember, I'm not using a compass, I use in my hand, like that for 9 exams. People who come in late, don't worry about yourself. Hey, we are more than last night, 202. Alright, so let's go to the next part of the question. Measure and state the length of the line segment AD and the size of angle ABC. AD is actually AD again about 7.5. So you would write that. You write AD equals 7.5 centimeters. Remember, I'm working in inches here, but I just doing that so that everybody can see. And the size of the angle ABC. You'd use your protractor, and I want to show good protractor skills, you know. I'll be right back. I'll talk to each other. I'm coming back. Where's protractor? Right? We have like a little more protractor here.
What do you big yellow thing? The big one?
Yeah.
understand.
Hmm?
Rainbow.
Yay! I wish I'd bring home the compass soup. It'd be real handy.
Yeah, let's put this in your bag. And yeah. And there's nothing.
Nah, I don't make a trip. Alright, I'm back. We back. And I find the big projector. So what's the angle we are supposed to measure? ABC. So this part, the center point of your projector, you need to put any one that the letter that they have in the middle. B. So B, and this will run along BC, and it measure A, where A looking like. Now my angle will be a little weird because I see I doing thing freehand and thing here, but again our angle are a little less than 70 degrees. Now remember, let me just make this bigger. Remember, you count from this side 0, 10, 20, 30, 40, 50, 60, a little less than 70 degrees, wherever that was. So you wouldn't go and say 110, eh? You wouldn't use the big numbers on top. You have to use this numbers coming from this side. It's an acute angle. 68 or something degrees is what I got. 68 degrees. So the answer for that is about 68 degrees. And for this I get about 7.5. Now, those who watching the video, even after the live stream, and you do it and you get a little answer that's different, I draw them thing without a compass, so it will be a little off, right? People getting 67, 70, 70, 69, 70, 67. Well done. Right, so I can do things freehand and work it out here, but we get 209. Anyhow, let's go on to the next part of the question. The next part is construction. Coordinate geometry question. P is a point 27. No, P is the point 24. Let me see if you could see this. Yeah, man. Or you could see that, man. P is the point 24 and Q is the point 610. So go ahead and work out the gradient and the midpoint. Look at this. The gradient and the midpoint of P and Q. There's a straight formula you're using there. Yes, I always post the stream afterwards. I have the stream from last night there. It's 3 hours. And when you're watching the stream, you may have to go and click to view the live chat if you want to see the responses that people are doing along. Because right now on the stream, you just see like 4 or 5 comments from during the day that people post. But if you want to see the comments you post, you have to click on the stream and then click on the live stream. Yeah, using that formula y2 minus y1, x2 minus x1. AdMats people, when they AdMats live, the AdMats live will most likely be on Instagram though, on my Instagram account. To give my Instagram account some assistance. Right now I only have 2K subs. So I'll do that on Instagram. But that'll be next week sometime. But I still need to arrange, because Instagram, it's a little harder to live stream to Instagram. Instagram vertical. 3/2, everybody getting 3/2 for the gradient. And what about the midpoint? So this here, gradient is equal to y2 minus y1 over x2 minus x1. This will be equal to, I put the substitution line in green. And what you usually do is come now and say this is x1, this is y1. Just to make sure you make no mistakes now, x2, y2, even the AdMats people. Then it'll be 10, take away 4, we just substitute it now, and 6 take away 2. And this leaves you with 3. Well, actually, 6/4, which breaks down to 3/2. So this is the gradient here, 3/2. And Let's put it in red. The midpoint, to work out the midpoint, there's a little more tricks involved in midpoint. Midpoint formula for midpoint, it's a little different. You tend to put this in the brackets like this, and you add up. It's an average of the two. Y1 plus Y2 over 2. So you use the points from before, and the points you had from before was 2, 4, 6, 10. 2, 4, 6, 10. So this would be equal to 2 plus 6 and 4 plus 10 over 2 over 2. Break that down. 8 over 2, 14 over 2. And everybody's correct with that 4, 7. Keep it in the brackets, right? Keep it in the brackets for them. So that's the midpoint. Let's back it up and see if we finish. Well, we finished up today, but I think this question went on with some more stuff. Oh no, that's finished. That's finished. So next up is a vectors question. So we're doing matrices construction and vectors tonight. Let me just put in the title, vectors as well. Vectors as well we are doing. Yeah, so go ahead and try this question. How we get the midpoint? We use this formula. x1 plus x2, y1 plus y2 for everything over 2, and then just go straight down. You're going straight down like this with the x value until you reach 4, and then you're going straight down like this with the y value until you reach 7. So go ahead with the vectors question. I spell vectors wrong. A P. Oh, sorry. Thank you. Yes, Angie. Good to see you in the stream too, bro. So go ahead and do this vectors question. What length you put in the perpendicular bisector for the perpendicular bisector for this? When you're drawing this, you just want to make sure it cuts in 2 points. So you're opening out your compass so that it cuts in 2 points. I really feel here not bringing the compass to here, but smallest of matters, man. You all are bright people. You all will be able to see what I'm talking about. Just take your compass here and you draw your curve there. You make some little estimates. So vectors question, January 2007. Sketch the diagram above in your answer booklet and insert the point X and OM. So you all would have already done that, those who following, because I know some people following. OX is 1/3 of OM. So OM going quite up to there, and OX is 1/3 of it. So we are expecting, when we measure off, it's like 3, and X would be here, where OX is 1/3 of the entire of OM. Alright, so that's the first part. The next part of this question, produce Px to Q such that Px is 4 times x cubed. Reading that sound kind of funny, but produce Px to Q such that Px is equal to 4 times x cubed. Produce Px to Q such that Px is equal to 4x cubed. Alright. So we're looking at a line coming from P to X. That's what they're saying. That's what they're feeling. A line coming from P to X. Like that. Alright, so we produce Px to Q. So Px is 4 times xq. Xq. Alright, so Q has to go a little further. because px is 4 times xq, and it needs to go in the same direction, so q is somewhere like there. So this is q. So let's just make sure I'm talking sense. Produce px to q such that px is equal to 4 by xq. Produce px to q such that px is 4 times xq. So that sound like it there. You all have that drawn? Yeah, so some of this will correspond with G, Rohan. Some of it will correspond with that exam as well. In fact, a lot of it. Yeah, but I watched some of the G advanced exam. It's pretty competitive. They need what they're giving in there is some dread stuff, bro. All right. So let me go forward. Hopefully you all see what I meant there. You can always go back over and watch this part, right? So cannot E in that. Unless you want to write in pain from the exam. The following in terms of R and S, OM and PX. OM and PX. So we want to write OM in terms of R and S, and then we also want to write P to what? P to X. P come back to X. So P go to X, or PX, like that. So give me some answers in the comments there. Write OM in terms of R and S, and we also want PX in terms of R and S. You can see the diagram there clearly. Yeah. Just for those who are watching it, straight up, this is R, this is S. So, looking for some answers. All the people catching up on Jamaican, Indian exams and thing. Where my answers crew? Where the answers crew? Yeah, we definitely doing angles of depression on the last day of the stream. 2 R plus S. Right, so R plus S, beautiful, we getting answers, now we're getting answers. So OM, and the reason, if we're going from O to M, most of the times in these kind of questions, you have to check the alternate route. Instead of going from O to M, we could go from O to P, then P to M. So you write it something like this. OM is equal to OP plus PM. So OM is equal to R plus S. So that's the first one. What about the second one? Now tell me what is let me just leave that right there. Tell me what is PX. I kind of give you a clue there. This is PX. PX is negative R plus S. Negative R plus S. I don't think that's correct. I'm not feeling that. What is PX? That's the next thing we're trying to find. So we found what OM was. We're going to find what is PX. What is PX? This is what the next thing we have to find. We already find this. We already do this. We already do this. But we're in the process of doing this. PX, people. So you can think of it a few ways. Christy, first person with the correct answer. So P to X, we can use this route, which I think is the best route to use. Go backwards on the R, so that means we're going a negative R here. And then we're going forward, but we're only going a third of actually OM. So that's the working right there. PX is equal to negative OP, because we went backwards. And you notice the arrow like this, so we have to say negative OP. And we have to add on OX. But OX is really a third of OM. So negative OP is really negative R when we start to put it into the letters, plus OX, it's a third of OM, 1/3 of OM, and I'll substitute what OM was from the last thing we did, which is R plus S. So I have negative R plus a third R plus a third S. This will leave you with S on 3 take away 2R over 3, right? So how did I get that? This is like 1R plus negative 1R plus a third R. That is negative 2/3 R plus 1/3 S. So I could actually write that as everybody over 3. Put the S in front. Take away 2R. Anything like that would be good. Yeah, well, I seen people with different variations of the correct answer. Yeah, it's a little complicated. I realize that some people maybe fall off with this one. It's a little complicated. But my vectors tutorial is really good, so you could take a look at that after. If the vectors question is like this is a no-no for me. Okay, maybe I should spend a little more time explaining this so people would see it some more. So I'm going on a new page. I'll just explain this in a very simple way so that everybody can see it. I'm not going to take much time. All the people bad talking lessons, teachers, and thing in this chat. And you're trying to put me in trouble. Okay. Let me say we have a triangle. So we're doing a little bit of teaching here. Pay attention. A, B, and C. And I want to know the vector AC. And I told you if I'm going from A to B, I'll call that A. And if I'm going from B to C, I will call that, I'm going to use A. I'm going to use another thing. Now you say P. And I will call this one P, Q, R, Q. Now you say Q. Going from B to C, Q. So what will be the answer for AC? You see, it's like a road. If I want to go to AC, I could go, if I want to go from Shogunas to Port of Spain, I can do that. Or I can actually go Shogunas to Rima and then go to Port of Spain. Why I would do that, I don't know, but you can do that in vectors. It's the same thing. It's the same value, just a different route. So I could go this route, or I could go this route. Now the reason I'm going this route is because I know what happens on this route. On this route I add P and then I add Q. So it's kind of like an alternate route thing we are doing. So AC is actually P plus Q. Where it gets a little confusing at people is they'll tell you and there's another point line somewhere here on AC. They might say there's a point on AC such that AM, and that's the point, AM is equal to let me see a third. That is the usual thing, that's what we just see there. Or sometimes they might say a half, but let me use that third. Okay, let's use 2/3. That's a nice one. 2/3 of AC. So AM is equal to 2/3 of AC. So where are we gonna put M? That's the point, that's the new point. All of a sudden there's a new point AM, that's 2/3 of AC. So you're gonna put M here. Divide this in 3 with your ruler if you're doing a sketch, or if you didn't make it, draw a diagram and put M right there. That's your M. So now we figure out where M is. Now the next step that they're gonna ask you, and I'm actually dropping bombs here. I'm dropping bombs. Trust me on this one. The next step they're gonna ask you is how to find, let's say, BM then. How to go from B to M. So in your mind, you're thinking B to M is like this. But with vectors, you need to pick a route that you know. So a route that we know would be like maybe like this. That will be B to M. Or I can go like this. That will be B to M. I bet this is the better one because, well, we already know what AC is. But it doesn't matter. Same difficulty. So B to M here would be, let me see if anybody have the answer to that there. What would B to M be? Q plus a third of AC. Yeah, Q plus a third of CA. That person understand it in a very good day because they turn around the CA and get CA. The AC, sorry, and got CA. Well done, genius. Or negative P plus 2/3 of AC, which is actually, we already worked out what AC is. P plus Q. So you all understand what happened in there? BM, I can go BA, then AM. So let me write that. BA plus AM, and we'll talk about it a little more. BA plus AM. And if you notice a thing with vectors, these two numbers are the same here. These two letters, sorry, are the same here when we add in. And therefore BA is negative P, because we're going backwards now. And what is AM? AM is along the line that we just found, AC. It's actually 2/3 of AC. So you put plus 2/3 of AC, but instead of AC, I can write what AC was one time, P plus Q. And then all you have to do now is simplify with some fractions here, which is negative P plus 2/3 of P plus 2/3 of Q. And you just want to think of this as negative 1P and 2/3. And you can put that in your calculator. You don't need to be no fractions boss out here. Negative 1 plus 2/3, put that in your calculator. You'd actually get negative 1/3 P plus 2/3 Q. And since you have 3 on the denominator there, in both of them, this technique, you'll have to practice this technique with a few questions and you'll be a little more comfortable with it. So this will be negative P plus 2Q. I just put everything over 3 and I put these, I group these numbers, this part of it on top here. And I could put the P afterwards. So sometimes you'll see 2Q, take away P. Alright, so we spend some time on that. Hopefully people who have a little stress with that, de-stress there a little bit. Let's go forward. They wanted QM. Wait, sir. This question went real out of hand, boy. You wouldn't get like this again for the for your exam coming in May. The reason I know that your vectors question wouldn't take up so much marks. Back then they had more marks to play with, so that's why they could elaborate on a question like this. But QM, anybody can find QM from the initial diagram? QM, or at least say the idea for finding QM. I'll go through really quickly because I want to keep moving. PX was like this divided by 4 now. 1, 2, 3, 4, and this was just a fourth of it. So if I want, so I already found PX or something. Did I find PX from before? PX turned out to be what was PX? PX was this big long thing here. So QX again stress, that's what watching the fractions here. QX going into, and then we're going straight to M. That's what I want. QM, we just make sure. QM, who come up with this boy? No one has 4 marks. That is wickedness day, boy. Wait, sir. Alright, so QX is negative a quarter of this, because it's a quarter of PX, but it's the other way. So QX equal negative a quarter of PX. Keep that in mind. And XM, do we have anything for XM? Please tell me we do something for XM already, please. No, we have nothing for XM, so we just had to suffer again. XM, this, so you all understand what I'm doing? I'm finding this part and that part. Now, that's why I do questions from back in the day, so you get to see how deadly the question could come potentially. Some people lost, but some people found. Some people not seeing. Turn your phone sideways so because I'm seeing it on my phone. And I could kind of make out everything even when it's like this. So maybe if you maximize the screen and turn like this, you'll be able to see it for sure. Then if you're not seeing still, you have to upgrade that blue, sis. Alright, so XM is the next one we're trying to find. We find QX and then we need to find XM. XM is actually we found OX, we found OM. XM is actually 2/3 of OM. Whew. So if we want to find QM, it's going to be equal to QX plus XM. And now you substitute. I'm just putting them in arrows there. So we knew that QX is actually negative a quarter of PX. So it'll be negative a quarter of that. So it's negative S plus 2R over 12. I'm just phasing it in very quickly. And XM is 2/3 of OM. 2/3 of OM. So that's 2. There's a reason that this question went for 4 marks. It's a nightmare. 2 thirds. And then you simplify this. This is an algebraic fraction. You simplify that. Oh, my screen blocking the thing, boy. So that's what I did there. Phew. So hopefully people will see that and understand. Some people, not me. This question: normal, blush, blood rush, and funny. Yeah, I wasn't trying to insult you. I just having some fun. This question, why this question so hard? Yeah, this question. I kind of picked this one watching it, but I didn't really watch it through and say like how much drama it would have been. But yeah, so this is a question that I want you all, especially those who feel they're ready, they're really ready, start to go back and look at them earlier years and see the kind of drama, so you could sharpen up your skills a little better. Because right now they're getting a little piece of a question, not the full works like what we are accustomed to today. Alright, I have to keep this up so because my neck. Yeah, and again a little bright light reflecting off there. Pops, really. Alright, we ready for the next part of the question now? PX. Talk about that. I'm saying that. Show that this is equal to that. That's another 4 marks. I will leave that for my Instagram. I'll post that solution on the Instagram because I don't want to throw off everybody with that part of the question there. So I'll post that part in my Instagram and we'll continue. This kind of proof thing could come, but not as crazy as it is right now. And remember I tell you that it could come, right? Let's go on to the matrices. Matrices. The chat blocking the left. Yeah, if you try to post too much numbers and things just so the chat will block you, try to unblock it. Joseph, there's an easier and faster way to do this. You could use different routes, but you're still going to end up with all those nasty fractions. But it's not that bad, so you could check it out. Pray for me, please. Right, that's a nice question to start early off with there to get everybody scared. Let's go on to the matrices question. Given that D is a singular matrix, determine the values of P. Rush that question nearly. Rush that question. Go ahead and try that question there. Given that D is a singular matrix, determine the values of P. I've seen people hitting me the answers for QM. Well done. 4/5 R plus 3/5 S. I'll go ahead with the vectors question. Once I peep this answer, let this person perfect. Maybe, but I think there's a number component in that. P is 4/9 or 2/3. 4/9 and 2/3 can be correct at the same time. One is either one. So P is 2/3. So the formula for determinant. What's the formula for determinant? Formula for determinant is determinant. I'm really trying to write with a highlighter, right? Determinant is equal to AD minus BC. Don't forget to press like on the video. Take your time and press that like button. I know that's a big hard exercise for some people. So we just use this. Now, if it's a singular matrix, when singular, the determinant is equal to 0. So determinant equal to 0 if matrix is singular. Well, if D is singular, I'm going to say D is singular so I don't write matrix. It's singular. So if D is singular, the determinant will be equal to 0. So it means that AD minus BC is equal to 0. So it means 0 is equal to A. Let's find a nice clean spot to do this. Determinant is AD minus BC. AD minus BC is equal to 0. So, and you know that this part is A, this part is D, this part is B, this part is C, right? So, AD is 1/4 minus BC. BC is 9p by p. So 1/4 take away 9p times p, right? Yeah, equal to 0. So you get 4 take away 9p squared is equal to 0. Yeah. Bring this across, you get -4, -9p squared. Yeah, so we're looking good. P squared is equal to 4, -4 over -9. So this will, the negatives will cancel, so it will mean that p squared is actually equal to 4 over 9. P would be equal to the square root of 4 over 9, which is actually 2 over 3. So everybody with the 2 over 3, then again. 2 over 3, 2 over 3, 2 over 3, 2 over 3. So everybody understood that, hopefully, and mean again. So now we are given two linear equations. This equation guys. So go ahead and solve these equations. You actually just write it in this form. AX is equal to B. This is common matrices all the time. Like all the time this is come. So go ahead and do that. Write an equation, right? Well, Ali won't really be able to Ali won't really be able to show me this, right? So I will just go ahead and do the answer. It would be nice if everybody could just, send up a picture what they do. Have some streaming software that could do that, but I'm going to show that. 2, 5. So this is what your answer should be looking like in your book. Now you should have your book out and you're working along with me. Don't just have me alone here writing. 3, 4, and this will be a xy is equal to 6, 8. So what I really do here is just rip out all these coefficients, put it in a little coefficient matrix there, put the xy here, and put this constant matrix here. So that's how that works. So this is in the form AX is equal to B. X is a variable matrix there. So the next step will most likely be to solve. My head blocking. So what your head do? So you're blocking. Yes. Sorry about that, people. Like last night I had the green screen up, but because I using this whiteboard, my hand get be in the way all the time. So I've gone up a little bit there so you can see what's going on. Jeez and ages. Yeah, my new calculator could solve this. Only want to see me do it. Let me show you. So we had, I'll write back the answer, the equation that we had right here so you can see it. We had 2, 5, 3, 4, 2, 5, 3, 4, x, y equals 6, 8. So to solve this, this is a y here. To solve this in the calculator, I tell you to on. Find the sweet spot, they go in. And I would go to mode, and number 6 is matrices. So I'll press that, boom. And I will have to, I'm gonna make sure they want us to solve this too. Yeah, so they're going ahead and ask you to find the inverse and they walk you through the whole thing. So they wanted to solve that. So I'll have to put in the matrices. This type of calculator is a Casio FX11. Watch the last video that I did on calculator. So I'll have to put, you can put in up to 3 matrices. The thing is, I just need 2. So I'm going to put in matrix A, mat A, and mat B. So I press 1 to select that. It asks me what type of matrix. So it's a 2 by 2 matrix. So that is option 5. So I'll click that. That is my webcam, so it kind of sucks. And now I just need to put in the values in the matrix straight up. So I'll do the question out on the board, but I just showing you all the matrix thing. So now I just put in 2, 5, 3, 4 in the calculator. So I wrote in the matrix there. And I just need to put in the next matrix now. So I'm putting in this matrix, the 6, 8 matrix. This is a 2 by 1 matrix. So I click that option and I put in 6 and 8. 6, 8, like this. So I put in 8 there. Did I? Yeah, so there's 8 inside there. You can't see it, but it's there. It's there, believe me. And now all I need to do to solve this, when you're solving for xy, it's actually equal to the inverse of that. So let me see, this was this matrix. Let me call that A inverse. Let me call this matrix A. So it's A inverse by, and we are calling next matrix B by B. Right, so A and B, those are the 2 matrices I have, right? A inverse by B. So I just need to tell the calculator to multiply the inverse of A by B and I'll have my answer. Where inverse is though? Oh, I had to use this button up here, that inverse button there. So right. So matrix A inverse by matrix B, and that will give me the answer there. Again, I kind of weird answer again. 16/7 and 2/7. So that look like that's the answer. So I multiply the inverse of the matrix. I'm not going to use too much time on this. I don't want to waste too much time on this. I'm going to work out the question, but I will do a tutorial on this calculator for those who have it, and I will try and use my sharp calculator to show you can do it on some of the other calculators, but this one better. Right, so this means we could double check our answers and see if we gain and get 16 over 7 and 2 over 7. And if you're watching the question here, they say show that the inverse looks like this. So if the inverse looking like this with once that 7s, it means that we're probably going along the right road with our calculator. So let's just solve this. They ask us to calculate the determinant and then show the inverse and then solve for x. We just going to solve for x one time. Y'all want me to do it on the board or write it out? Let me see what's going on in the chat. Do it on the board. Do it on the board. So y'all want me to work this out on the board? Yeah, I'll work this one out on the board. Everybody so love board. Don't fall long on the board. This whole board could have fallen long. So y'all see now board there clean? Do it out on the board. Anything from the iPad there. But I don't want this. I have another thing. Alright, so I really erase of the matrix there. So I'm just going to go through a whole inverse here. 2/5. Why did I say 2/5? XY 68. 608 is actually 2. This is 2534. This matrix here is A. To solve this, we need to know the inverse of A. So A inverse, we'll have to find the determinant of A first, which is actually equal to AD minus BC, which is equal to 2 by 4, take away 3 by 15, 3 by 5, seen into the future here, right? 8, take away that, so this is where they get the 7 from. So we have the determinant. Next up, we have to find the adjoint. So the adjoint is actually equal to, you swap the B and the A and you switch the signs on the B and the C. Everybody following? Board right, board right, board right. Right, 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 board, 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 board. So it's a kind of in between a right and board. So so some I might do on the board, some I might do here. This is like a board question too. So I guess you feel it out with the board now. AD minus BC and the adjoint. So this is the adjoint of A. Now we substitute in the actual value. So you just swap this and switch the signs on that. So this is 4, this is 2, -5, -3, and we not get it. So now I just need to do the final bit, and I have some space here. So the final bit is to actually find the inverse. So the inverse of A inverse is actually equal to A inverse is actually equal to 1 over the determinant by the adjoint. 1 over the determinant by the adjoint, 1 over -7 by this 4, -5, 3, 2. Everybody going to go over 7. But remember it's negative, so it could be -4 over 7. Or you could put the negative in front. This will turn positive because it's a negative and a negative. So I get 5 over 7. This will be 3 over 7. And this will be -2 over 7. That's the answer for the inverse. So remember that is the inverse, that is what we want. That there is the inverse, that's what we want. And if you look at this part in the question, they actually ask us to prove that. So you can know whether it's going the correct way or the wrong way. So we got that out. So all you need to do now is solve it. So we want to solve this equation on top here. So I'm erasing this little part how I got the inverse now. And we just want to solve the system of equations. Now we have a few of this to do tonight, so I'll don't get worried. -3, did I make a mistake somewhere? You see, I can't even double check back and see if I make a mistake. I can't even remember what I do there. Anyhow, so xy now is equal to A inverse by 6/8. There's a kind of line I skip out here. There's a line I skipped out here where you show that you multiply both of them by A inverse to cancel. But this is okay as well. We can just reach to this, right? And now we write in what A inverse is. So we have -4, 7, 3, 7, 5 over 7, -2 over 7, and we're multiplying this by 6/8. So people who watching this live stream over, yeah, when I divide by the negative number, it cancels. So that's why this positive now. Yeah, remember it was -7, so the -7 cancel out the negatives that was here and here. You get double negatives. So that's why all of that went like that. Alright, so all you need to do now is multiply and you'll have the answer. You multiply this by that and that by that. One of the first tutorials I did was on matrices, and it's well done. So you can go back and learn how to do this, review how to do this over and over. Alright, so -4, 7 by 6, we put it over 1, plus 5 by 7 by 6 over 1. I don't even know why I'm writing out all of this. Then you'll have 3 by 6 over, well, this is 7. This by this now, and then add on -2 over 7 by 8 over 1. So add up these guys. The answer to this is the answer to the question. So I have some space here, I'll do that there. -4, so that's -24 over 7 plus 30 over 7. That's the first part. And this one is 18 over 7 plus -16 over 7. This answer boils down to, everybody getting this? I make a mistake? 5 over 7 by 8 here, yeah. -5 over 7 by 8. Why did I put 6? Sorry, so this is 40. So this answer here is -2 over 7, and this answer here is -16 over 7. That's what we got on the calculator. Yeah. So the calculator did it ahead of time. 16 over 7, 2 over 7. So you're seeing it in the fraction mode there. Right, and you leave your answers in fractions and matrices. No bother to go and put them thing in decimal, like confusion. Right. So the next one I'll do it on the iPad, because I think it's easier for me on the iPad. Alright, let's see what's going on with the comments. Earlier we now reached 10 o'clock. We have plenty to go. We have plenty questions to go. So let's keep moving. So this is the answer to x and y. The exercise I'll do it here, but we already did it on the board, so that was that. Using a pencil and a ruler. So I'll be going through a little faster now. As I said, I start off slow, but then we speed up a little bit. The good thing about it, all these questions I'm doing for people who have major problems in them, I have a tutorial and everything that I'm doing here, so you can always go and watch it out. To get the calculator, all you have to do to get the calculator is watch the last video I did on calculators. There's a number in the description there, or a number during the video. You can just go and call that number and buy this calculator in Trinidad. Alright, use a pencil, a ruler, and a pair of compasses only. Using a construct a triangle PQR. So we're looking at this question here. QR is 8.5, PQ is 6, and PR is 7.5. So it don't really matter, we could construct this any way we want. PQR, so that's PQR. I'll do it on the border. You always draw a sketch with this. Is the most vital thing to draw a sketch for is this. You know why? Sometimes at the end is where to make a next little piece, like a trapezium or parallelogram. And if you didn't do a sketch, you might end up drawing into the next question. And that is so. Trust me. You're in the middle of the exam running out of time and you realize that you're drawing going to crash into the next question. Failure. Alright, so PQR, that one's a different way this triangle will come out. You see when they put like more specifics, people could have put the P here, anything and everything would have to be given correct. PQR, and one's the different lengths. So what would happen here is that you'll draw your baseline. Everything is done light first and then you darken afterwards. That's the technique you should use. Draw your baseline. PQ is 8.5. Sorry, PQ is 6. That's right. I mean PR is 7.5 and QR is 8.5. Like a sleepy off. I'm making mistakes. PQ is 6, PR is 7.5, and QR is 8.5. Alright, so we measure off 6 here. Now, I always say to measure your things and make sure it's good, and then show a little construction too. So you have your measure it, and then you stick a compass here, make sure that measured, and you draw a line too. Just avoid making that mistake now. But they're looking for this. They're looking for that curve to show that you cut off and you actually construct that 6 centimeters here. Then this point, you're going to get 8.5 centimeters. You're going to get 8.5 centimeters. Open your compass to that and draw a curve like that. Bigger, 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 bigger. Right, so that's 8.5. So this is at a radius of 8.5 centimeters. The next, you see, is that 8.5 I want, is 7.5 I want for that side. Right, so 7.5 is about there. So you'll open your compass to that and draw a curve at 7.5. This side is the 8.5. This side is the 8.5. You have to open your compass to that and you draw a curve going like this. Where it cuts is the point that we want. I can immediately begin to put my dark lines. I will draw my dark line there with my ruler, obviously. And then I put in my labels. So this is 7.5, this is 8.5, and this here was 6. Now, put your little arrow. Nothing too spectacular. Make sure it's nice and neat. Not really looking like this. I'm actually pretty neat in the maths, but my handwriting sucks. So yeah, construct the line PT. So we're looking at the next part of this now. Construct a line PT such that PT is perpendicular to QR. So you already see what's going to happen there, right? You want a line PT going like this, and that will be T up there. Meets QR at T. Measure and state the angle, da 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 da. So let's see again. Our next chance to see this again. Our next chance to see how we're doing this again. You stick your compass here, and and you make a curve there. Let's do this in purple. Everything looking purple. Let's do this in green. You stick your compass there and you draw a curve, and you just want to cut the line that you want to bisect. You want a perpendicular bisector going like this now. So bam, and you could come off the compass and then come back on there. Just make sure that this is a curve you're drawing there. It cuts at the 2 point. You stick your compass here now and you make a next curve there. You stick your compass, make a next curve there where the two intersect. That will be a perpendicular bisector coming down there. It only gets good with practice, people. Then you draw your 90 degrees. Yeah, any length. You're looking at any length for this. I mean, you're not going to open it big so that the compass miss the whole thing, but you're looking at a decent length. Not too small too, because if it's too small, you won't get a good measurement to get this curve going there. And that'll be a perpendicular bisector, and this point here will be T. Now you just need to measure and say the size of angle PQR. Angle PQR. Oh, I didn't write any points here. So this was P, this was Q, this was R. Angle PQR. I'll have to come from this side now. I'm coming from this side. And I'm getting about 60. I'm getting about 60 right here, people. So angle PQR is about 60. The actual angle PQR. PQR is 60 degrees. And this measure and stay the length of PT. That's over here. So that's the green line that I just drew. I'm getting about 5.4. My answers wouldn't be that accurate because you see how I draw that, right? And this is 5.4 centimeters. Next question. $5.2, you all get 5.2? Right. Let's move on. Next vectors question. I'll rush this question. Vectors in the dance. Now we start to see some answers on that vectors question. This is May 2007, by the way. Lexian Brown, I feeling your pain, I feeling your pain, I see in your comments. Everybody sharing answer and you don't know what happened. You need to watch my tutorial on construction. Watch it on construction. Just mark that down. Watch Cohen Springer tutorial on construction. I went through a whole nice long video and explained that out there. And all of this was explained in that video as well. So it will be a little more in depth. This here is a crash course, so we're rushing through some stuff. You know, we're just going through some answers and refreshing people. How much years we do so far? I think we just do 1 year so far. This is the second vectors question we on. Answers, and they hit me some answers there. Let me read this. OK and OM are position vectors such that OK is equal to K and OM is equal to M. Okay. Sketch the diagram above. Show the approximate positions of points R and S such that R is the midpoint of OK and S is the point on OM such that OS is equal to a third OM. R is the midpoint of OK, so we're going to put R somewhere about here. So boom, whole R. And S is a point on OM such that OS is a third of OM. So OM is that. So we're going to divide OM up into 3 nice little pieces there. Boom, Bam. And OS is a third of OM. So S has to be here. And that's the answer for the first part. So that's why I wasn't pen and said it was a graphical answer. Here we have to write down in terms of M and K and M the vectors, these vectors here now. So let me see if I can get these vectors on the next page. Save the photos, bring it across back here. So we want to find some vectors earlier based on all of this. So people who was here just now, this is a good time to figure out these vectors in the corner here. Use this diagram and figure out those vectors in the corner there. Let me see if anybody trained on answers. Negative M plus K. People not playing. So every time I think it has some people, you know, just every time I think I'll dying down, it have people there pumping out questions. So negative M plus K, K take away M, both of them are the same thing. Correct. Correct too. M to K. M to K means we need to go this direction. Remember, we're using a different route. We don't really, it didn't even have a line cell for M to K, so we don't know. It's a mystery. So, but we can find it by going along the next route here. We could go backwards and this way. So MK is indeed equal to negative M plus K, or K take away M, whatever floats your boat. Next one, Add Maths Friday. Actually, there's a very strong chance that I'm going live on Instagram tomorrow with the Add Maths. I'm trying to go live on Instagram with Add Maths. There's a very strong chance, but I don't want to make no promises with that until I sort it out for sure. But I may just use the board for Add Maths. So I might just use, anyhow, RM. So R to M is this way. So we have a little piece of OK there. It's actually half of OK. And we have all of OM. So RM is actually equal to negative OR plus OM. But negative OR is really half of K. Well, negative K and 2. Or negative half K, whatever. Plus OM, so that's plus S. So I look like that is what RM is there. So we take that for RM now. So RM is done. Next. Somebody said they don't understand. Shanika Stewart. I don't like when people say they don't understand. I don't like it. If you don't understand, you need to tell me why you don't understand. So this part, this vectors, what happened there? Ask questions. Don't just say you don't understand. That's a kind of weird thing to say. So if you don't understand, see in lessons class, whatever, do just raise up your hand and say, sir, I don't understand. Say, sir, what happened at this point and that point? Because I mean, you must be following from some point. And if you say the whole thing, so then why didn't you raise up your hand from way before at the start, right? So, but I'm coming down and you're saying you don't understand. I just showing you how you need to think if you want to improve your mathematics. In anything in life, too, you just fall off and say you don't understand. Yeah, so we already find negative a half K plus S plus M. I put S. M. Let's work out what KS is. Yeah, she kinda. Alexander, I made a mistake with the S. There's M. So KS now. K to S. Well, we have a little piece of, we have OS there, which is actually the third. So K to S, we have the K. We have that K there. Zion just crying down the place, but I hope you're right. My wife is there. So we have K, and we have a third M. We have K and a third M. So we just need to add those two together to find what KS is. So you do a similar style of working. KS, and I'm going to just skip it. KS is KO plus OS. KO is negative K plus a third, not S, M. Right, so that's KS. Yeah, so next one, RS. Finally, what is RS? People already work out RS already. R to S. These questions are really repetitive. They don't waste time repeating questions like this again. So they will ask it once and then ask it something different. Because this is come like a testing the same thing over and over. Anyhow, RS would be a half of K, so that's negative that, plus a third of M. But it's negative a half. So most people get out RS already. I don't understand how the OR to be a half. OR. Yeah, because the whole thing is K. So if you want to get OR is actually half of it. So that's why it's a half. My video blocking again. Alright, yeah. I'm trying to move it. So this is what I have underneath. My head blocking. I'm so late. Good night, everyone. Good night, Janelle. You ready to move on or no? Ready to move on to the next question? 182 people online here. Way. Alright, what's next? L is the midpoint of Rm using a vector method. RS and KLOC. So let me find L first now. L is the midpoint of Rm. So between R and M. Between R and M, where's R? Where's M? Come to me, Mr. R. Come to me, Mr. M. So that's Rm there. Using a vector method, prove that RS is parallel to K. Oh, we didn't even write down what L was, where L was. So L lining along here, right? And we want to show that RS is parallel to KL. KL, RS. I'll put it in a different color line now. What color are you feeling? I'm feeling red. Nah, we are red already. Let's go orange. So we have KL and we have RS. So even in my diagram here, you can see that it's really looking parallel for real. But you can't write in your exam and say them it looking parallel for real. But now you'll actually prove. You'll actually use a vector method and prove it now. So you need to find out what is RS. We already found RS. People already gave me what is RS. I didn't write it down. And yeah, my video would be safe on YouTube to rewatch everything, so you could always go back and watch. And RS, KL. Remember, there's a slight delay in, so when you all put the message there, there's a slight delay. The last stream will most likely be on, I don't know if I'll stream Saturday. I may have something to do Saturday evening. So, and I'm not too sure if the last stream is Friday or if I'll have a next stream afterwards. But I need one more day after Friday actually. So yeah, so we already have RS. And just remind me what RS was. Let me just go back up and see what RS was. RS was negative K and 2 plus M3. Oh, RS was this part plus this part. So let's write that in the corner here. RS is actually equal to negative K and 2 plus M and 3. Why do they use K and M? Why such weird letters? And now we need to find what KL is. So that's basically what we're doing here. Well, I draw the arrows in the wrong direction over here. KL. These arrows here should really be facing the other way, like this. How do we find KL? Well, this goes down to halfway, and this goes down. We already have RM, so this is just half of RM. So you need half of RM. I want someone to work it out. I want you all to work it out. We want half of RM, and we also want this K to R. So K to R and half of RM, which is in other words RL. So let's work it out. KR is actually negative a half K. KR is equal to negative a half K. And R to L is a half of RM equal a half of RM. I'm squeezing up everything here. I hope that again people confused. It's equal to a half of RM. I can take your time and watch it through afterwards. A half of RM. Hey, I'm back in the way again. Alright, so let's work it out quickly. A half of RM. RM is actually negative K and 2 plus M. Negative K and 2 plus M. So a half of that is actually negative K and 4 plus M and 2. And we need to add these two together to get what KL is. So KL is equal to a negative a half. So this is negative 3. Okay. Adding it one time in our mind, which I should not do. Negative a half plus. So this is negative 3/4 K plus M on 2. So now to use a vector method to show that they are parallel, RS and KL. To show that they are parallel, they need to have a common factor, a common scalar factor. And I'm not really seeing a common scalar factor here. So did I make a mistake? RM negative K and 2 plus M. No, I did not. Are these identical? No, they are not. Let's see what people are saying here. Alright, I will need to actually do this on a clean page and just explain it a little more in depth, because I think I'm messing up and confusing people more. I'm doing more damage than help here. Only maybe the top students maybe keep it up. So clean page. I hope you all have the stamina for this and not get weary. Alright, so what we are trying to do, I'll do some little explanation. What we're trying to do is RS and KL show that they are parallel. That's what the question asks. Show that RS and KL are parallel. So we already have what RS is. RS is this. So all we need to do is find what KL is. KL is going this way. Right? A half, negative a half K. So KL turned out to be negative a half K plus a half of RM. And RM was this. Plus a half of RM. Equal negative a half K plus a half. RM actually stands for negative K and 2 plus M. This is negative a half K plus negative K and 4 plus M and 2. This is equal to negative 3K and 4 plus M and 2. And we already know what RS is. RS. Oh, so I had to turn around RS because I yeah, so no, correct. RS is negative K2. Negative K and 2 plus M and 3. Now, to show that this, use a vector method to show that these are parallel. Okay, let's get this, let's keep going. This is 4, negative 3K plus 2M. This is equal to 6, negative 3K plus 2M. So, you can see clearly here that they are the same. They are just related by a scalar factor. Now, this question, why I always anyway, so why? This question is a rough one, boy. Like, cause as you're going it, you may not be able to see it from here and here, the parallel. And for vectors to be parallel, you had to see a scalar factor in each of them. So the scalar factor for example, if I multiply this by 4, and I multiply this by 6, they will both end up being the same. The same vector. Yeah, real sleepy here, boy. So your explanation will be the vectors are parallel because they share are related by a common factor. Common factor. This vector is a quarter times negative 3k plus 2m. This vector is 6 times negative 3k plus 2m. Alright? So My IG is Cohen Springer. I don't know if it's my IG you're talking about or you're talking about Genius Kid IG. Alright, so that is a day for this vector question. Yeah, this vector question on my back. Alright, so now you keep moving. A, B, and C are three matrices such as that. Find 3A, B inverse of that, 3 of that. So I'll put on this here so I could use this to press. And I'm working quickly here. So you all go ahead and work with this and see if you can get the answer before me. A, B, and C are three 2x2 matrices such that A is that, B is that, and C is that. Find 3A. 3A. Well, 3A would be equal to 3 by A, B, C, D. If then gain nothing, then gain nothing. By the way, that is the answer there too. But to be nice, we just go through. One wash my face. Alia. Right. Daddy. Yeah, one bro. Nah, we good. What happened? Yeah, head inside. It's too dark? Okay, go by mommy. Alright, next one. B inverse. So we need to find the determinant. So we need to find the determinant and the adjoint. So if B is equal to 5, 3, 3, 2, to find the determinant of B. Determinant of B is equal to AD minus BC, which is equal to 5 by 2 take away 3 by 3. And 10 take away 9. The determinant is 1. I'll get 1. Well done. Put on Peppa Pig. Nah, he love to watch planets and things, so he's watching that and I'm going ahead with that. The adjoint of B. You will swap, change the sign, -3, swap, so pair 2, pair 5, and therefore the inverse, or B inverse, would be equal to 1 over the determinant by the adjoint, which is, he's got some kind of planets thing, and he's watching next something else on YouTube called number blocks. Oh my gosh, he always watching number blocks. He really loves letters and that kind of thing. Before he could talk, he could read words and things. So like we driving past and he just reading words and stop and that kind of thing. So before he could talk, he kind of reading. He understood the words. Alright, 1 over the determinant by adjoint. 1 over the determinant by the adjoint. This must be trying to get into the maths. So 1 over 1 by the adjoint. 2, 5, -3, -3. Well, since it's 1, it's actually just going to be the same as 2, 5, -3, -3. Yeah. So, everybody good with that. Acto 1, everything good? Excuse your head, please. Sorry. The last time I had... You know what? Let me just fix this once and for all. Let me just fix this once and for all. Alright, my head should be like totally all the way there for most things. Yeah, it's the same answer. Next, we keep going. The diagram below, I hope you all can see that clearly. It kind of looking messed up. The diagram below shows a parallelogram EFG and its images after undergoing 2 successive transformations. So the first one was here, and then it was transformed into, this is the first transformation here. This, and the second transformation is over here. Let's see what they're going to ask us. Describes in words the geometric transformation EFG onto E prime, F prime, G prime, H prime. In words. What happened here? What do you think happened here? So anybody who thinking reflection, no. Anybody who thinking rotation, I miss out two parts of the question. Oh my god. No. We coming back to that transformation thing. But let me do the little two parts of the question. Those who saying translation and glide. Yes. Alright, so we found B inverse, we found 3A. So 3A plus B inverse, oh my gosh, that's so easy. So you're adding this and that. And then you had to do a kind of hard thing. So yeah, we had to do all this question. This question is vibes. Alright. So we want to add 3A plus B inverse. Remember, in that 3A was 3A, 3B, 3C, 3D plus B inverse turned out to be the same thing because the determinant was 1. So it was 2, negative 3, negative 3, 5. 2, negative 3, negative 3, 5. And then add it up. And then add it up. So you'll have 3A. Excuse me. Shall we alright? Peppa Pigs. So 3A plus 2, 3C minus 3. So what we're doing here is just adding directly. We're adding this with this, this with this, that kind of thing. 3B minus 3 and 3D minus 5. I think he lost one of his toys or something. Why I saying minus is plus 5. So that's the answer. That's what we wanted. Okay, and then the value of A, B, C, and D, given that is equal to C. So finally, C get a moment to shine. 14, 0, negative 9, 5. 14, 0, negative 9, 5. 14, 0, negative 9, 5. So now, change that to arrow. Don't like seeing it. We can figure out what A, B, and C is very quickly. So you can say 3A plus 2 is equal to 14. So 3A is equal to 12. A is equal to 4. Kind of rush it there. Maybe I shouldn't rush it. Why rush it? We have the whole night. So 14 equal to 12. 3A is equal to 12. A is equal to 12.3 equal to 4. Next one, 3B. 3B minus 3 is equal to 0. So 3B is equal to 3. B is equal to 3 over 3, which is equal to 1. Dead, my phone battery dead already. Yes. Next one, 3C minus 3 is equal to negative 9. 3c is equal to negative 9 plus 3, negative 6, 3c. Everybody good? That's not finding back my chat. 150 people. Yeah. So we again. Where I get the 14 from? And do I have 14 here? So that's where I get the 14 from. 3a plus 2 is equal to 14. Then 3c minus 3 is equal to negative 9, so we're going along. So this means c is equal to negative 6 over 3 equal to negative 2. And I'm not seeing no answers from people. Again, concern 3d plus 5 is equal to 5. This means 3d is equal to 5 take away 5 equal to 0. 3d is equal to 0. D is equal to 0 divided by 3. D is equal to 0. So those are your 4 answers for A, B, C, and D. Remember writing with my finger, so the handwriting will look kinda, your handwriting will feel kinda jumpy. Alright, so now back to this translation question. So the first type of translation, the first type of transformation is a translation. Or a glide. You need to state a little more than that. Yeah. What I'm showing you all, part of what I'm showing you all here is that even if you're a little tired and things, you still have to keep the grind. So I don't know if some people are getting it and some not getting it. So you have to keep the pump. Those who stay and those who manage to put out a little extra work, it will benefit you. I mean, I already have my distinction in maths and I already do up the engineering maths. So and again, but this is for you to get in again as well. So try and keep it up. I mean, if you had to sleep, you had to sleep, but some people are sleeping now. EFG onto this. So the full specifics of this transformation is needed. You can't just say EFG is a glide or a slide or a translation. You need to see what actually happened. And what happened is that it dropped down. It went down by, this value here is 1, and this value here now is negative 3. So it went down by a whole 4. So you need to see that. You need to see that you can use it with glide or slide translation, and you write it in terms of vector format. What happened? It moved across by 0, but it dropped down by 4, like that. So it didn't go this way, it didn't go that way. You'll see now. It didn't go this way, it didn't go that way. It just went down. But you need to see how much units it went down. It went down 4 units. So you use negative 4 right there. The next one, from the first transformation to the second one, what happened? What type of transformation is that? That will send this to that. What type of transformation is that? What type of transformation is that, people? People that practice the Spanish orals. Where is Spanish orals coming up just now, boy? Good luck in that Spanish orals as soon as school crack open there. You know them orals in Spanish and French is coming real early. Rotation, rotation, rotation. Y'all, when you're seeing the transformation, you will lose marks if you just see the general idea for it, right? You need to see more. If it's a rotation, what kind of rotation? What happened? Rotation is the one you had to see the most with. Now, for those who say reflection, it's not a reflection. If it reflected, this you would have been able to draw a straight line perpendicular to the axis of reflection, which most likely would have to be that. So H would have to be somewhere up here. See what's going on there? It's not a reflection. And if it reflected, the H and E is just in the wrong spot. The answer is a rotation. A rotation 180 degrees clockwise. Everybody who's saying that? Good. In fact, if it's 180 degrees, you don't really need to say clockwise, because anti-clockwise, clockwise, same thing once it's 180 degrees. It's not 90 degrees. It's not 90 degrees. If it was 90 degrees, it would end up here. Ordering this way. It will end up over here. I got this. 1, 2, 3. No, I don't got this. Alright, I actually need to rotate this to see what will happen. Alright, I don't got this. I'm not visualizing this right now. If it's a rotation, it would have ended up in 90 degrees, it would have ended up over here. I'll actually have to draw 90 degrees here and measure all those things to be able to figure out where it is. I'm not too sure I'm visualizing that right. But if it's 90 degrees, it would have ended up here. But and it wouldn't be facing that way, it would be facing kind of lying down. So this is 180 degrees clockwise. Let's move on. So you'll see rotation, 180 degrees, rotation, 180 degrees. I know coming down to 12 o'clock, the numbers started dwindle and it started drop to 100 and thing. But we still have 145 people up in the dance. 180 degrees rotation. Yeah, so write the matrix which represents the transformation described above as J. So we already write the matrix for J. So that's 0, -8. So in other words, they probably just want describing words. My bad. They just want you to describe in words here. So it means when you write glide translation, you need to say a glide translation, but you also need to say that it went downward 4 units. Understand? Glide transformation went downward 4 units. And it didn't go across any units. The matrix transformation now. The matrix transformation. Now, let's talk a little bit about matrix transformation. This is a good topic to spread some knowledge on. What type, and I need you all to interact. Now, because of the delay, the interaction will be a little hard. What type of matrix is this? What do we call this matrix? This is the matrix we build everything off of in transformation. -4, up -4. Yeah, -4. So yes, that's the identity matrix. I said something back then that's supposed to be -4. So this is the identity matrix or the unit matrix. Let me use the word identity, right? The identity matrix. Any matrix I multiply by this gives me back the matrix. So if I take the identity matrix and multiply another matrix, an unsuspecting matrix, by, let's say this was the 0.23, the answer that I'm going to get now is going to be 23, because 1 by 2 will give me the 2 and the 0, so I'm not going to get anything else. I'm going to get add 0, So any matrix you multiply by the identity matrix, you get back the matrix. The identity matrix is where we base all the transformation matrices off of. So I can tell you for a fact that maybe about 80% of children don't ever reach down to the transformation part in matrices. The teacher just don't get time, they miss out that class, that's just before exams start, whatever. So you see this matrix, this is the identity matrix, this is what we build off the transformations off of. And I taught a little of this Monday in the CSEC prep. So what do I mean by that? If I just put a negative sign there, you know what's going to happen? When I'm multiplying this point, my answer now is going to have a negative there. All of a sudden, what does that mean? In terms of a diagram, what does that mean? That means this. If I had a diagram and I had points on this diagram, I had the point 2, 3. So 2, 3 would be somewhere about here. If I use this as my transformation matrix, all of a sudden the point is going to end up over here, because this point here is negative 2, 3. The initial point was 2, 3, and just knowing this will help you be able to figure out matrix transformation questions a little quicker. So this is actually a reflection in the y-axis. This matrix is a reflection in the y-axis. If I throw a negative sign here, if I throw a next negative sign on the identity matrix here, all of a sudden this is going to be negative as well. So it's going to map down here. Let's make it a little more realistic. Somewhere down here. Negative 2, negative 3. What about, let's clear this slide. Let's erase some of this. Eraser, be bigger. Let's go. What about if I completely messed up the numbers in the identity matrix and I put, like we know the identity matrix was 1, 0, 0, 1. What about if I messed it up and I put it like this? And this came in 2019 January, I believe. What about if it came like this? What will happen if I have to multiply a matrix now? If the matrix is like 2, 3, what is going to happen to it? Let's see. You'll have 0 by 2, that'll be 0. 1 by 3, that'll be 3. 1 by 2 is 2. And 0 by that is, so in other words, the answer that I'm going to get is 3, 2. It swaps. So this actually switches the x and y. So this matrix is a reflection in what line? It's a reflection in the line y is equal to x, because it's swapping the x and y. This is especially for students who pretty good in maths. This is something to remember, right? Everything happens off of the identity matrix. So the answer will probably be up here now. This would be the point 3, 2. And this is actually a reflection in the line y equal x. This is the line y equal to x. So there's a reflection in the line y equal x. So that's something you can remember and keep in your back pocket. Yep. So this is the part of matrix transformation that I didn't really teach that much on in YouTube. But the initial part of matrix transformation, where you have like double transformation, like you go through one transformation and you go through a next transformation, I taught that. But like the concept behind matrix transformation and how we take the identity matrix and manipulate it, yeah, to get the basic transformation, this is essential in that. One more thing. If I go back to the identity matrix now, so you know the identity matrix was like this. What about if I change it to like 2, 0, 0, 2. What is going to happen here? Inside here, you can imagine it's going to change that to 4, and it's going to change that one to 6. So this is an enlargement scale factor 2. And you can enlarge maybe 1 point at a time, you can enlarge both at a time. So it's good stuff to know, good stuff to have in here, good stuff to have in your back pocket. Alright, so let's see. Write the matrices represent the transformation described above. Oh, this is what you're complaining about. Negative 4. Right. And K, which maps this to that. So that's a rotation. So we immediately seeing that this is swapping because let's examine the points. 3, we're looking at H prime, right? Because we want to know, right? So we're looking at H prime. 3, 1, negative 1, and now it's going to become negative 3, but a positive 1. So what happened there? It swapped, but not only did it swap, the signs change. It swapped and the signs change. So the matrix that we're looking at is a matrix that swaps, the matrix that swaps. This is the identity matrix. But if you wanted to swap, we'll have to put it the other way like this. And since the sign change, you'll have to put negatives on those ones. So hopefully people see their way through this. And I know some people just memorize about 8 transformation matrices straight off. But if all you know is the identity matrix and you have a little understanding and you're okay in maths, you'll be able to battle with this and be able to do this. Numbers is 1:30 right now. We have 45 minutes at the 12 o'clock. Let me see what will happen here. Who accidentally clicked the dislike button? Alright, so the point P is mapped onto P prime by the translation G. State the coordinates of P prime. Well, if we have 6, 2, and we're using the transformation G, so anytime you see a vector transformation like this, you have to add it, not multiply it. So we add in 0, negative 4, so it means this was P prime is going to be 6, negative 2. Yeah, I realized this live, like last night live, people was like in the dance like, way, Unreal answering question, like this live scaring people. Even some of the top students realizing there's some work to do. Some people sleepy. I wonder if you was talking to the birdie, if you'd still be sleepy. Alright, the point Q is mapped onto Q prime by the transformation K. State the coordinates of Q. So you could go ahead and do this one as well. You could go ahead and do this one. So you map in the point Q onto Q prime by using the transformation K. So when you're using a matrix transformation, you have to multiply. And you put the matrix first, right? So you put 0, negative 1, negative 1, 0. And you hit the point 5, negative 4. And then you get your answer. But we already know what the answer is going to be. It's going to swap it and change the sign. It's going to swap it and change the sign. Isaiah, what's going on there, bro? Yeah. So before I go on, any questions? Right now it's sounding like gibberish. Yeah, it's 4, negative 5, eh? Because remember it'll swap and the signs will change. We're doing CSEC on the 15th. Down to the birdie, but that's the thing. We losing no sleep unless it's important. One thing, boy, the sense of humor always there. Why is somebody talking French, boy? Or how they are French around coming up? Do a video on matrix transformation. Been there, done that, man. Just search my name on matrix transformation and you're good to go. And the other piece of matrix transformation, I just taught it there. Just give me some motivation to study. Please, if you don't study, you will fail. And to know that you're going to fail and you can actually pass. You actually have the potential to pass by just studying and going through your stuff. Not a good feeling. Walking out the exam and seeing stuff that you know you could have do, but you just didn't prepare. I think we're ready to go on to the next question. Using a ruler and alright, so I put on my board, but what I'll do is do the sketch and walk it through. Using a ruler and a pencil and a pair of compasses, construct parallelogram WXYZ, in which WX is 7, WZ is 5.5, and XYZ. Okay, so you draw a sketch of a parallelogram first and see if it can fit you. So WZ is 7, WZ here is 7, centimeters, and WX, because this is W, what am I saying? WX, Y, Z, WX is 7 centimeters. When you sleep, you kind of things happen. WZ is 5.5 centimeters. And XWZ is 60. As this here. This is 60 degrees. XWZ. Measure and state the length of the diagonal WY. So this is where you need to construct. So I'll just walk you through the construction steps. You draw a sketch and make sure you have it. WX is 7. WZ is 5.5. Yeah, I was talking about before when I put in. Yeah, construction is such a beautiful topic. Yeah. So what you wanna do? I'll draw my guidelines in gray. Yeah, you draw a baseline. Then you use your compass to measure the 7. Like one will be a spot and one will be a cut on the 7. Then you come to make a WZ at 5.5. But first you need to make a 60 degrees. At 60 degrees, you make one curve. You stick in your compass right there, right? And you make one curve that comes like this. So let's do that. Stick our compass there, make a curve that comes like this. Then stick your compass here, and using the same length, make a curve that comes like that. Now, I have a total tutorial on construction that you can just beat out after this. Then you draw a line going up through there. Now this will be a light line, so you let it go up a little bit. Then you'll come with your compass and measure out 5.5, stick it back in here and measure 5.5, so you'll get a curve somewhere about here soon. And that will be, let me make it a little shorter. That will be a 5.5. Next, that one. Next up, stick your compass here, measure 7, stick your compass here, measure here, stick your compass there, measure 5.5, and all of a sudden you have a trapezium constructed. Put in your dimensions, put in everything, live your life. WY, people don't do it and saying WY is 8.9. I can live with that. WY is something like 8.9, right? Yeah, it could be a little more than 7. So WY is from there we are measuring. So W, X, Y, Z, 60 degrees, 5.5, 7. It turns out that WY is. So this is how a parallelogram could come. Somebody getting 10.5, 8.9 and 10.5 is two different things. So I'm not putting my head on my block for W again. I don't know. Alright, let's go on. So here's a little weird question. How will I be able to do this on this page? I don't know, but yet we still try something. Given that x squared, this is a little bit of coordinate geometry meets functions. So this is more of a functions question than a coordinate geometry question. There's a little intersection, so that's the coordinate geometry part. Alright, so 120 people. What? We're making it up to that 12 o'clock by force. Alright, so you start to follow this now by substituting into that. You substitute 0 into that, so it'll be y is equal to 0 squared minus 4 by 0 is 0. So your answer here is going to be 0. Substitute 3 into that, you get 3 squared minus 4 by 3. Work it along with me, people. Make sure I'm doing the correct thing. So you'll get 9 minus 12. So again, another answer here, minus 2. Oh, so apparently this is the low point. It's going back up. Alright, yeah. This is the minimum point. We know that. And 5, well, if this was 0 and this is 5, well, you can expect this one to be 5 too. You don't even need to work it out. 5 squared is 25 minus 4 by 5, 20. So those are the answers there. So using a scale, plot this. So let me just make a little sketch of how it will look in the corner here now. Let me see how that looking on the screen. Now, but I added right on a separate sheet of paper. So you're looking at the extremes. We're going down to negative 4, coming up to 5. We start at negative 1, we end up on 5. Negative 4. So I can draw this here, so you can come across there. So, and the lowest we reach was negative 4. So negative 4, 2, 1. So this is how you plot out your graph now. So you don't go out of hand, and 1, 2, negative 1, 0, 1, 2, 3, 4, 5, and the highest we went up to was 5. 1, 2, 3, 4, 5, and then we rewriting them numbers there. 1, 0, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then we started plotting points. Negative 1, 5, negative 1, 5. Plot that in a different color, maybe green. Negative 1, 5, somewhere up here. So then 0, 0. That's a big drop there, my friend. Then 1, negative 3, and then 2, 1, negative 3, so everybody with me? I know some people going off on Spanish here, and they do what they do, you know. Vibes. Right, so where are we now? 1, negative 3, 1, negative 3, looking at 2, negative 4, but 2 was a little off. It could be a little more here, so and 3 will start to go back up, 0 and 5, go all the way back up to 5. So you can see what's going to happen there. I'm running out of colors, but alright, orange come through. Just try and hit the points. I didn't hit the points, but I'll catch what happening there. So that is my graph. On the same axis, draw the line y is equal to 2. So the line y is equal to 2. We have any more colors you could use? Blue. Y is equal to 2. That's this line here. I could actually use a straight line for that point. Y is equal to 2 is this line here. Slim down that line. Slim harsh. So it's supposed to be a horizontal line, but for some reason this line having problems being straight. Right, y is equal to 2. Y is equal to 2 is that line, and this is the line y is equal to x squared minus 4x. While the curve y is equal to x squared minus 4x. Yeah, I find this graph have a nice pretty look about it, but this graph looking sweet. Alright, so say the coordinates of the 2 points at which the curve meets the line. That's him and him. My graph not drawn to scale, but you can actually solve it, or they say using the graph. Say the x coordinates. So the x coordinate looking like negative a half and 4.5. Negative a half and 4.5. Negative a half and 4.5, or 4.5. Those are the x coordinates where the curve meets now. So negative a half and 4.5. That's the x coordinates where the curve meets the line. Next up, hence write the equation whose roots are the x coordinates as stated above. Easy. You just equate the two. So y is equal to 2 and y is equal to x squared. So equating the two, we'll have x squared is equal to x squared minus 4x is equal to 2. So you bring it across. X squared minus 4x minus 2 is equal to 0. So that's the answer for this part of the question. Any questions? Are you with me? Yes, I seen answers. People with me. Alright, let me do a roll call here. Call out your country and your school. Roll call. Let me see who in the dance still, who's still paying attention. They say 107 people here. This was the graph we get. I'm just waiting because there's a delay. There's maybe about a 10-second delay from till I actually do something till you see it, right? Trinidad, Holy Faith Convent, Jamaica, Trinidad, Tabakit SEC, Tabakit in the house, boy. Tabakit, St. Lucia, VFC, SS, ULE, upper level, Trinidad, Sawan, Trinidad, Jamaica, Trinidad, TSS, Trinidad, Media High, St. Stephen's, Jamaica, private class, Trinidad, Bishops, Savannah, Trinidad, Antonio, Trinidad, Journey, Trinidad, Genius, Jamaica, Genius from Jamaica, Vidal, Trinidad, Jamaica, Guyana, St. Joseph, Guyana, El Dorado, St. George's, Guyana, Woodbrook, Tunapuna, real people, oh my gosh, real people, friend caught high, Jamaica, real Jamaica in the place. QRC, Mosava QRC representing Ashta, Mosava Ashta as well. Alright, Vinci, Adalted, Trinidad, Grenada, Trinidad, evening classes, Rio, East, St. George's High. Everybody here. So everybody ready to do a vectors question now? I want to see the same energy, converted it to that vectors question. Now you notice, I don't have CXC, but I hear you have CXC. You had to have more energy than me. So if when I finished 12 o'clock, you had that energy to go back through and watch over some questions and point, seal in some new things you learned today, take down some of your weak areas, as genius kids say, take down some of your weak areas and rush it, and practice it. Anyhow, you want to do good in the maths, though the maths CXC on a whole, everybody on a whole testing more reasoning and logic than just regurgitating. It's getting harder to just win by doing past papers. Literally half asleep. Or they come to life. So we're doing this question now. A triangle ABC not drawn to scale. Let me make sure my head out of the way. P and Q are midpoints A, B, and BC respectively. Make a sketch, show the point P and Q. So I just going to paint in right on the diagram here. P and Q. Midpoints of AB, P, and BC, Q. So they're going to ask you some kind of type scene again. Given that AB is 2x, so let's write that in. A to B is 2x, and B to C is 3y. Once again, these vectors question that the last vectors question you do was real peacefully. So state what is AC. This always start you off nice and easy. So AC will be go A to B, then B to C. So that will be 2x plus 3y. 2x plus 3y. And then we want P to Q. Well, that's basically half the ship. That's half of it. That's half of AB and half of BC. So you're looking like 2x divided by 2 plus 3y divided by 2. So this will simplify to give you x plus 3 and 2y. Yes. So I've seen people going along the correct answer. Hence, show that PQ. Now this is a more respectable question. This question behaving himself. And this is how I expect to see it come for your exam in May. Either this or the next style of vectors, something more like this. PQ is equal to half AC. Well, that is like a big duh right there, right? So you're just, what does a half AC is? A half AC is equal to 2x plus 3y over 2 is equal to x plus 3 over 2y, which is equal to PQ. So this was nice and easy. After that killer question that come, this is a nice and easy one. Yeah, it did better come like this. Don't worry. When the last question, let me just find it back to scare anybody who wasn't here from before. This question, to show that the parallel, that's a piece of nightmare there, boy. Watch this routine here. So I don't think they're bringing it on that level. So watch how this looking like a nightmare. They're bringing it on that level, so they're getting it more like this level. A little more complex than this, but nothing too difficult. The position vectors, this is the other style of vectors that can come. We didn't get any like this. Why I put it over 2? Because it's half. You see, half AC, so that is half of AC. AC was this, and I put it over 2. Right? Anyhow, two position vectors, the position vectors of points, the position vectors of the points RS and T relative to the origin. Well, you didn't really need to say that because our position vector mean, right? OR is this, that. Woi. Expressing the form AB. What's the time? 11:37. Racing down to that 12 o'clock. Let me try and finish. OR is equal to expressing the form RT. So RT is a displacement vector, And we know the rule is this last one, take away this first one when you're using the position vectors, OT minus OR. Remember that rule of vectors. Excuse me. So AB is equal to OB, take away OA. The tutorial I have on vectors covers this. You'll be able to watch it over. That's the rule there. Something we call the triangle law. So OT minus OR. So instead of OT minus OR, I would actually write. Now you'd go down in your paper by just going across because let's see what's going on here in the space, right? That'll be 5, negative 2 minus OR 3, 4, which would be equal to 8. 2, negative 6. Yeah, now you do some foolishness there. SR, same thing. RS minus OS equal to, I say RS, OR minus OS equal to 3/4 minus OS, negative 1, 6 equal to 4, negative 2. 4, negative 2. I see in 2, negative 2. 4, negative 2. 4, negative 2. The point F is such that RF is equal to FT. So no one can answer. Oh, this is the coordinates of F. RF is equal to FT. Use the vector method to determine the position vector of F. RF is equal to FT. RF is equal to FT. So we have what R is, we have what T is. A little sketch will come in handy here. Nothing too spectacular. In fact, I'll go in and see if I can just ratch the sketch. Like just put R anyway. Like I'll put R here and I'll put T here and F will have to be in the middle here now. So I want to find OF. I want to find the position vector for F. Alright, you want to find OF. So to find OF, you'll see what's happening there. Or should I go on a new page? I should go on a new page. Make these a little bigger. So I'm not even worrying about coordinates. This is just concept. R, F, tangent F, R and T, sorry. R, T, and then we have a miserable point called F lying in the middle there. We have the position vector, we have the the origin here, right? So what we really want to find is OF. This is what we want to find in OF, this here. That's what we want to find, OF. So to find OF, we just use OR and RF. But RF is really half of RT. So OF is equal to OR plus half of RT, which is really RF. Understand? We want to find this, so we just use that and that. So now we could bring back in coordinates. Why people think I tired? Let me tell you a secret. You see this level? This is the same level as be recording half the videos at like the videos were at super energies because I recorded in a day. So when I at this level is because yeah. But the maths is I guess I must be tired, but I wouldn't like feel it like that because it's maths for me. But for you I don't know what will happen, right? So OR is actually 3/4. Why am I saying 3/4? It's just 3/4. It's not 3/4. And half of RT. RT, we work that out to be that 2 and negative 6. So half of 2 and negative 6. So this is equal to 3/4 plus 1 and negative 3, which is equal to 4. I say 3/4 again. Yeah, that's where the tiredness is. 3/4 plus 1 and negative 3 equal 4 and 1. Yeah. Yeah, boy. So we going. Alright, so what's next? Let's say the coordinates of F. F. Well, if you find OF, bring back the page was writing, please. This page. I have this, I have this, I have that, I have this, I have that, I have this, I have that. Alright. Alright, so hence state the coordinates of F. We already just found the position vector of OF. OF turned out to be what, 4 and 1. So if that's it, just state the coordinates of F. Just put it a lie down, man. 4, 1, and then the answer there, position vector and coordinates. Yeah. X equal 4, Y equal 1. Next question. What's the time? 15 more minutes, people. 15 more minutes. A, B, and C. I think this is the last question, but I'll be taking a little requests in the 15 minutes period there so we can do some things. We are on 102. He's always finish off on 100. Tonight we peak at about 200. The middle question was real rough, so I think that scared away some people. But we get some work done. We got some stuff done. Make the last one a coordinate geometry. Alright, we can look for hard coordinate geometry and do it. So start up on this question here. Given that AB is equal to C, calculate the value of X and Y. So this is B, this is A, this is C. So we have some multiplications to do here. Some wacky multiplications because this is actually a 1/2 matrix, which they don't really deal up with the 1/2 sometimes. A, B, C, so let's multiply this, my friends. A, B, 2, 1. So we have 2, 1. I guess we can use a little thicker pencil. So we have 2, 1 by 1x negative 2 is equal to pi 6. And now we need to solve this. Solve this to show what x and y is. So it's always row by column, row by column, row by column, then row by column again, row by column. So the first one is 2, that's 2 tick. The first column would be like 2 by 1 plus 1 by y must be equal to 5. Work it out. So 2 plus y is equal to 5. Y is equal to 5 take away 2 equal to 3. Next one will be 2 by x. Let's put in the x next to the 2, which means multiply, plus 1 by negative 2 is equal to 6. Yeah. So you'll get 4. 2x minus 2 is equal to 6. 2x is equal to 6 plus 2 equal to 8. 2x is equal to 8. X is equal to 8 divided by 2 equal 4. So x was equal to 4 and y is equal to 3. Next one. Given this matrix, show that it is non-singular. So we just need to get the determinant. The determinant is AD minus BC. And when it's non-singular, the determinant would be a non-zero number. So if the determinant was equal to 0, it's singular. If it's not equal to 0, it's not singular. So AD, so this will be 2 by 3, take away negative 1 by 1. So this is 6 plus 1, 7. Everybody gets 7, so therefore it's not singular. So since the determinant is not equal to 0, it's non-singular. And I get 6, I get 7. Alright, find the inverse now. So let's do this one more time. 2, negative 1, 1, 3. 2, negative 1, 1, 3. Find the inverse. We found a good bit of inverse tonight, so I guess you'll get some practice in that. First thing you do is you find the determinant. 2 by 3 minus negative 1 by 1. That will give us, wait now, we find the determinant already. What are you doing? 7. Then you write down the adjoint. 3, 2. Oh, always write the formula. Swap, switch signs. This is going to be 3, 2. Sign switch there. Therefore, the inverse is going to be equal to 1 over the determinant by the adjoint. Please see before you come on live. Genius, be yourself. 10 more minutes to finish. Hold it out, hold it out. I feel like I could go a whole hour again. Bet. We could go a whole hour again. Equal 1 over 7 by 3, 1, negative 1, 2. Put everybody over the 7. 3 over 7, negative 1 over 7, 2 over 7, 1 over 7. So that's the inverse there. Let me see if they want you to do anything. Show that when you multiply the matrix by the inverse, you get 1. Right, and hence use it to solve that method. So let's do that. What's the name of the matrix? They get a name. The matrix is called R, people. We call any matrix R. So I draw a line here, just so that we know that was that part there. So now we want to do something else. We want to do the dumb thing and multiply the matrix R by its inverse, which is just annoying, but nothing is annoying when marks are involved. So it was 1 over 7. I think this one was negative 1 over 7, and this one is 2 over 7. Are you daring me for the 1 more hour? I am very serious in 1 more hour, you know. Alright, so then we multiply this by that. So this is equal to this is nasty. So this is equal to 6 over 7. So I'm multiplying one time, right? I will say what I'm multiplying, but I'll put down the answer. So it's 2. Let me just use an X pen for this, an X color. So this is 2 by 3 over 7. So that's 6 over 7 plus. It turns to plus because it's 2 negatives. So it's plus 1 over 7. Next up, I'm going to take this, the same, I'm looking for this section here. So this row by that column, right? So this is 2 by 1, 7. So there is 2 over 7 and negative 1. So this is negative 2 over 7. So we already seen that 0 going and hit out there, and we already seen that 1 hitting out there. Beautiful. We're on the right track. So this is 1 by 3 over 7. So this is 3 over 7, and 3 by negative 1 over 7 is negative 3 over 7. Another 0. Yes, so let's just see if we can get 1 to come there now. So bottom row by this column. So 1 by 1 over 7, so that's 1 over 7, plus 6 over 7. So now, let's add up these things and see what happens. So this is 1, 0, 0, 1, which is the identity matrix. Yeah. So let's go on with the next question. Using the matrix method, solve this pair of simultaneous equations below. So it's 0 and 7, right? So you use the same thing. So first you set it in, you write it in matrix form, 2, negative 1, 1, 3. You put the xy, and the two numbers on the outside here was 0 and 7. Understand? So we just take out the coefficients here now, and these two numbers are 0 and 7. And you solve this. We did some of this already for the night. So this is xy, and this is r inverse here by 0, 7. But we already found what r inverse was. R inverse was 3 over 7, negative 1 over 7, 1 over 7, and 2 over 7. And this is 0. When you see 0, smile, because that means the multiplication game get easier there. So it's 0 plus 7, 7, so this is 1. Alright, let me write it out. This is 0. I'm doing row by column here, right? This is 0 plus 1, 0, 1, 0. I have to change my entire study timetable in order to be on this live. I have to wake up in 3 hours or so, so I go on. All the people who had to wake up and they had to go, blessings. Thanks for staying so long. 4 more minutes to 12 o'clock. We'll see what happens. We are 98 people. 0, 1, 7 times 7 is 1. Negative 1, 7 minus 0 is 0. So this is plus, and 2 7s by 7 is 2. So the answer is 1, 2. I should have make you all work out that one and before. Yeah, I know some people look it out 1, 2, 1, 2, 1, 2. Yeah, so you could feel free to exchange numbers and thing and Instagram handles and thing. Who knows? You know how romantic it is if you meet your wife on Cohen Springer Mathematics Live videos. Man, I could come your wedding. That was the end of the question. We finished just in time. That was the end of the question there. So, lives now. Requests now, I mean. Any requests? I think Genius had say one more coordinate geometry question. Like anybody have anything specific that they want to do? Or I think maybe we should cut it off at 12 now. Yeah, maybe we should cut it off at 12. The topics we're doing tomorrow: functions, just functions, algebra, relations, functions, everything in functions, including completing the square, all of functions. Linear programming, we're doing that. So you're doing all of relations, functions, and graphs. And I might do some series and sequences. In case Alain realize, we already do question 1, question 2, a good chunk of question 3, and if coordinate geometry come in question 3, all of question 3, and all of the last question. We already kind of do some revision in that. It's just for you to finish up the revision in that now. I done jumpstart you. I too ugly for this sharing thing. Don't worry. Ugly people in style these days. You pass that maths, all of a sudden you get more attractive. Yeah, so functions tomorrow. Tomorrow functions. People will wonder bearings. Don't worry, we already do a whole live on bearings already, but we hitting that again. We hitting the bearings and thing again, but not tomorrow. Tomorrow we're doing functions, relations, graphs, and series and sequences. We covered on a lot of things. Genius, make him move, brother. Make him move. A senior, Shemaya. Think back. Alright, I'm a teacher. Let me get back in my teacher role. All you stop tracking each other in my online class, please. Yeah, so coordinate geometry. I feel we didn't do enough coordinate geometry. So tomorrow, but when we do the functions, relations, and graphs, we'll touch back some more coordinate geometry, especially like perpendicular lines and gradients. We didn't really get a chance to do that. We get a chance to do all the hard stuff in construction. We get a chance to do some very crazy stuff in matrices and vectors tonight. So that was good. If you are a person who just sat down and watched the live all through and you didn't even pick up a pen or a book, that means you're not getting the full potential out of the live. You need to actually do some questions, practice doing some questions as well. After 16 years, maths nice. So when you see people flying out to Jamaica, these kicks. Hindi class? I don't know anything in Hindi. Oh yeah, I know the skill. Sorry, Gamma Padanisa or something. I think that's doing me fast last you do in Hindi. That's about it. That's why I know in Hindi. So can't help you out in Hindi, can't help you out in watchmen pelting out the number on this live. I never advise you to pelt out the number on your live, on this live. I say get Instagram handle. You don't go in the DMs before you get the number. Alright, the next class tomorrow, we're doing how to track. That's the class we're doing, right? How to track, because somebody needs some instructions. Anyhow, tomorrow, same time, 9 o'clock, 9 to 12. We may go a little longer tomorrow. Tomorrow I may start 9:30 because I actually have a band practice to go to, and that might take some time. But if all is in see me 9 o'clock is because I come in on 9:30. Don't frighten. We not get. So tomorrow we might go a little later. For sure. Yeah, tomorrow we might finish a little 12:31. You could always watch the stream again. For those who watch the stream again from start to finish and wasn't in the live, real belly. To watch 3 hours of a video, sit down and not be in the live chat and thing, that is rough. But good night. See y'all tomorrow. All 100 people still watching. Blessing.